In this video, we're going to look at examples similar to 5.55. So let's take a look at the problem. So in 5.55, about 10% of persons between 25 and 30 years old live alone. Let S be the event a person lives alone. If 5 persons in that age group are randomly selected, find the probability of the sequence SFFSF. So S means the event that a person lives alone, which also stands for success. F stands for failure, and in this case, it means a person does not live alone. So let's write down, we're going to use P to represent the success probability, which is 10%. P equals 10%, that's 0.1. So P here means success probability. Okay, so we can find out the failure probability. That is going to be 1 minus P. That's well, I'm going to change the number to make it a little bit different from the homework. So I change it to 1.2, and in this case, in my case, the probability of failure is 0.8, 80%. Okay, and here, go back to the question. We select 5 persons randomly, and we want SFFSF, and I'm going to change this a little bit. So instead of having SF, I can just randomly select anything. So let's just, I'm just going to do one. Let's say we have F, S, S, F, and F. Let me see the problem. So it's a little bit different from the order is a little bit different. So what does this mean? That means the first person we select is a failure, which means this person does not live alone. S is success. That means this person lives alone by the definition given in the problem. And the third person does live alone. The fourth person does not live alone, and the fifth person does not live alone. So in order to find out the probability, so we know that each of them, when you ask, because when you select these 5 persons randomly, the answers you get from these 5 people will be independent from each other, which means the answer you get from the first person is not going to affect the answer you get from all the other 4 persons. Similarly, the second person's answer is not going to affect the others. And so because each of the answers, 5 answers, are independent of each other. So when we try to find the probability, we can use the one of the formulas we learned before. The probability is going to be the product of the probability of all these. So what we need to do is, before you ask this first person if he lives alone or not, and we know that the probability of this person saying not living alone, which means a failure, is, we use the answer right here. We got 80% chance this person is going to say he does not live alone. So we get 0.8. And the second person, before you ask this person, you know that it's going to be 20% chance this person is going to say he lives alone. And the third person, 20% chance this person is going to say he lives alone. And the fourth person, 80% chance this person says he's living alone. And similarly for the last person. So because all of these 5 answers are independent of each other, in order to find the answer for all 5 people, So when will this event happen? What's this event? First person says does not live alone. Second person, third person both say they live alone. The fourth person, the fifth person, they both say they're living alone. So, and that's for this event, specific event, the probability is multiplying the probability for each single simple event, and we get the answer. Okay, so you can use a calculator to find the answer. I'll skip that. And that's part A. So you can follow this example to do that question. And the formula we used here is when you have two events and AB represents intersections, so the probability of the intersection is equal to the probability of A times probability of B if A and B are independent of each other. And B are independent. Apparently, in Bernoulli trial, we know all the trials are independent of each other. So you can, all these 5 trials right here, 5 trials means you ask 5 people, and the answers you get from them should be independent. So that's why we can multiply the probability of all these 5 answers. Okay, so part B is a little bit different. If we take a look at the problem, part B, it says find the probability of exactly 2 successes, which means exactly 2 persons from these 5 persons you selected will answer yes, they live alone. So I'm going to let's say in my case 2 successes, and we know that part A, what's the difference between part A and part B? So in part A, these 2 successes are specifically from the second person and third person. But in part B, it says exactly 2 successes. Well, which 2 people will answer yes, they live alone? It could be many different possibilities. So maybe the first person, there are many possibilities. For example, we may have S, F, S, F, F. Or we may have SS, FFF, and there are lots of them, which we know by the combination formula. 5 choose 2. We know actually 2 of them. We have 5 people. We selected 2 of them, and to make them answer yes. Well, not make them. Well, suppose 2 of them will answer yes out of these 5 people. How many different ways? So if you make a list, you're going to have 5 choose 2, which is, let's say, 10. 5. So it's going to be 10 different ways. So if you're going to make a list, you're gonna get 10 different ways. And so here I listed like 3 of them. Part A is one of them. This is one of them, and this is one of them, this is one of them. You can keep listing all the different ways. So and so in this case, you can see the difference between part A and part B. Part A, there is exactly which 2 people said yes, they live alone, are given, second and third. But part B, you don't know which 2 people. So you have to find the probability for each of the ways and add them together. So for each of them, we get an answer from here, and you will add all of them together, which is pretty much multiplied by 10. So in this case, if you can use our binomial distribution formula. That's exactly how we got this formula. Because binomial distribution formula does not care about which trial is a success. Is the first trial a success, second or the third? We don't care. We only care how many of them ended up successfully. So we going to use the binomial distribution formula, which is n choose x. So if let me write down the formula here: n choose x, and p raised to x, and 1 minus p raised to n minus x. So p means success, 1 minus p is failure. So we're gonna do n, which is 5 5 people, 5 trials. You're going to ask 5 people, each of them is a trial. And we select 2 success. Always remember X here means how many successes, not failures. So we're going to plug into P. P is 0.2. That's the success raised to 2 successes. And 1 minus P is 0.8. And 5 minus 2. If we have 2 successes, we must have 5 minus 2, 3 failures. So we're going to calculate 10 times 0.2 times 0.2, which is, let me just write it out. I guess I can save this to you, 0.8 cubed. Okay, so, and you can find out what the answer is. Alright, so you can see the difference here. In the second question, in part A, that we have 2 successes, 0.2 squared, and 3 failures, and 0.3 times 0.8 times 0.8 times 0.8. In part B, we will still do that. 2 successes and the 3 failures. So see, 0.2 is success probability squared, 2 successes and the 3 failures, and so 0.38 cubed. But we will multiply by 8, by 10. Why do we multiply by 8? Because in this case, we don't care about who says success, who says failure. So you will have 10 different ways to have the 2 successes. So that's why we got to multiply by 10. So for each of them, you get a probability, but you should always get the same answer. And so that's why we multiply by 10 to get the answer. Okay, so that's 5.55.